In this video, we are going to discuss about the latch design. On completion of this latch design, students will be able to explain the latch design and they can find out the differences between the latch and flip-flops. So first we can see about the latch design. So this latch design is one kind of logic circuit. It is containing the bistable multi-vibrator. So you can see in the diagrams, it consists of the logic circuits, that is it has a low clock ahead, it consists of voltage drop, non-restoring, back driving, and also it has an output noise sensitivity, very dynamic and diffusion input. Because it has two stable states, namely that we have it as high as well as low, this works in the low storage device by holding the data through the feedback lane. So you can see the feedback here. Mainly it stores one bit of data as long as we are activating it. Once if you are if the latch can change the, once if you are giving the enable data means, then it can change the stored data. So on continuously if you are using the inputs, one enable signal is activated, the next signal will be changed from the storage data. So the working of these circuits can be working in either in high or low, either if it is in the active high mode, or both the inputs can be in the low mode, or both the inputs can be in the high mode. Similarly, when the latch circuit can be in either active low state or both the inputs are high. So here this transmission gate, there is no voltage drop and access requires inverted clock here in the transmission gate of latch design. Here also we can use it can be separately used for the control signals for depending the state inputs and outputs. And the next one is inverting buffer. So why we are using this inverting buffer, you can see in the diagram. So why we are using this inverting buffer is to restore and to back drive it. Also this fixes, if you are fixing this inverting buffer, there will not be, the output noise will be very sensitive and there will be a diffusion input. If you are giving 1 as an input, then it will be giving the 0 as an output, and 0 as an input means it will be getting the 1 as an output. So in the state of tri-state feedback, you can see that the static as well as back driving risk. So in the case of the static and back driving list, the both high input which you are giving to the latch, the output goes very slow and the memory of this latch will be very efficient, will effectively reset. When both the inputs, if the latch are giving as low means, then it sets to the earlier stage, or we can say it is a reset stage. So next, this latching states can be essentially used in all the buffered input, and this buffered input will fixes the diffusion input, and also it is a non-inverting. In the case of buffered output means there will not be any back driving, and this can be widely used in the standard cells. So in the case of the standard cells, we can see very robust, and it will be either large or rather it can be slow, and it has a high clock loading. And in the case of data path latch, compared to the data path latch, in this circuit this will be very smaller but faster, and it has an unbuffered input. In the case of flip-flop design, so this flip-flop design is mainly used to pair up the back-to-back latches. Here you can see the latches are paired back-to-back. So the main thing of this is if we are giving this any enable line to the driven high output means the information can be either latched. So the control line mainly used here should be very necessary to set either it's synchronous, or the input should be, which is present, can be alter the output even in the enable pulse. So mainly this backup of the two latches will pair the first latches as well as the second latches. When the input is set as low means this outputs from the gates must be also less, and also this can be stayed away from the earlier information. Similarly, when we are comparing the enable input as high means it changes the position of the latch. As the enable line is stated, this equals the process of same latch enabling the line to be active or low. Quiz questions on latch design. It explains the different types of static latches and registers. Thank you.